In this problem, we need to factor completely this trinomial here. And notice the numbers are fairly large in this, so we hope there's a greatest common factor. And after looking around, we notice that 45, 33, and 36 are all divisible by 3. So at least I can pull out a greatest common factor of 3. And 3 goes into 45 15 times, so it's 15x squared plus 3 goes into 33, 11x, minus 3 goes into 36 12 times. So at least my numbers are a little bit smaller. So now we're going to concentrate on factoring this trinomial. But don't forget, we're going to have to bring down this 3 in front of our final answer. So what we're going to do is we're going to look at this trinomial in here, not the original one. We're going to look at this, and we're going to compare it to ax squared plus bx plus c. So what is a? A is the coefficient of the x squared term, so a is going to equal 15. B is the coefficient of the x term, so b is 11. And c is the constant term right here of negative 12. And so what we're going to do when we're factoring, we're going to multiply a times c. So I get 15 times negative 12, and 15 times negative 12 is negative 180. That is going to be our product. So we're looking for a product of negative 180. And then b is going to equal the sum, and so they're going to add up to 11. So looking at the signs, my numbers multiply to a negative. That means I have to have one's positive and one's negative, and they're going to add up to a positive number. So out of the two numbers I have here, the bigger one, the one with the bigger absolute value, has to be the positive. So I'm going to start out with negative 1 times 180. Those definitely multiply to negative 180, but unfortunately the sum is way too large. So negative 2 times 90 is negative 180. They're going to add up to 88. Still way away from the sum I need. Okay, 3 goes into there 60 times, so negative 3 times positive 60. Those add up to 57, not even close. 4 goes into 180. I think it's negative 4 times 45. And that's going to give me a sum of 41. So 5 goes into 180. I think 36 times. Negative 5 times 36 is negative 180. Those are going to add up to 31. Getting closer, but still way away. 6 goes into 180 30 times, so negative 6 times 30. Those are going to add up to positive 24. 7 does not divide into 180. 8 does not divide evenly into 180. But 9 does, so negative 9 times positive 20 is negative 180. And negative 9 plus 20 is positive 11. Now these two numbers are the numbers I need, but remember they're not the factors. They're the two numbers that are going to help me do our factoring. So what I want to do with those two numbers is I'm going to take this middle term, my 11x, and we're going to rewrite it as negative 9x plus 20x. As you can see, negative 9x plus 20x give us 11x. So don't forget, we still need to leave the 3 in front at GCF. And now what we're going to do is we're going to write this, but instead of 11x, we're going to write this expression. So I'm going to have 15x squared minus 9x plus 20x minus 12. So all I did was break that middle term down into two separate terms. And the reason I did that is now I have 4 terms. How am I going to factor that? By grouping. So remember, we look at the first 2, we look at the last 2, and remember that greatest common factor 3 just stays in front. But looking at my 15x squared minus 9x, what do they have in common? I think it's a 3x times, and what's left? I think I have a 5x minus 3. Don't forget, always bring down the middle sign. So it's going to be plus, what do the last 2 have in common? I think they have a 4 in common. And if I pull a 4 out of a 20x, it's going to leave me with 5x. Pull a 4 out of a negative 12, it's going to leave me with negative 3. So now, is this binomial factor the same as this? Yes. So I have 3 times my common binomial factor of 5x minus 3. And what's left when I factor this out? I get 3x plus 4. And so now I have completely factored my original trinomial. And in this one, I'm not going to check it, but how would you check it? You'd FOIL out these 2 binomials, then distribute 3 into the answer, and we should land up with our original polynomial.